Hey there, I'm Jason, streaming here as Brainbetter, as I do Monday, Wednesday, Friday, Sunday, other times. I don't know. We are here to do some more Advent of Code today. So, catching up with the weekend and, the Friday and the weekend's problems. So, let's just go ahead and dive on in here. Um, had a slightly late start, got caught in some traffic, and then my hard drive was full as I went to kick off the stream, so I had to do a quick bit of shuffling things between drives. Well, one of my hard drives was full, so I had to move things from that drive to a different drive. And it's not even the drive that I just installed a giant video game on. So I don't know what is up with the world. But I'm here. I'm ready to do some coding. Let's go ahead and bring up the screen. Okay. And I got the Lorelei and the Laser Eyes soundtrack running here. Hey, Shateri. Good to see you. All right, so today's going to be day 14. So let's go ahead. We got the template here. Control Shift Save. Day 14.ipynb. All right, we have a day 14 thing ready to go. It won't be happy until we tell it about its kernel. We'll close that thing up, let that thing run. All right. So, yeah, today's goal is let's find out. Day 14. Restroom redoubt. One of the historians needs to use the bathroom. Fortunately, you know there's a bathroom near an unvisited location on their list, and so you're all quickly teleported directly to the lobby of Easter Bunny headquarters. Unfortunately, EBHQ seems to have improved bathroom security again after your last visit. The area outside the bathroom is swarming with robots. To get the historian safely to the bathroom, you'll need a way to predict where the robots will be in the future. Fortunately, they all seem to be moving on the tile floor in predictable straight lines. You make a list, your puzzle input of all the robots' current positions and velocities, one robot per line. Each robot's position is given as PXY, where X represents the number of tiles the robot is from the left wall, and Y is the number of tiles from the top wall. Okay. Each robot's velocity is VXY in tiles per second. Okay. Robots outside the actual bathroom are in a space 101 tiles wide by 103 tiles tall, but in this example, 11 walls tied and 7 tall. The robots are good at navigating over or under each other, so they can share the same tiles without interacting with each other. Okay. And these robots have a unique feature for maximum bathroom security. They can teleport. When they would run into the edge of the space they're in, they would instead teleport to the other side, effectively wrapping around the edges. Okay. The historian can't wait much longer, so you don't have to see them with robots for very long. Where will the robots be after 100 seconds? Count the number of robots in each quadrant after 100 seconds. Okay. Robots that are exactly in the middle don't count as being in any quadrants. The only relevant robots are those. All right. Total safety factor of 12. Predict the robots in motion of the robots in your list with a safe that's 101 tiles wide and 103 tiles tall. What will the safety factor be after exactly 100 seconds have elapsed? Okay. So there is no need to simulate this. I know I commonly don't go for analytic solutions because usually analytic solutions require you to know like linear algebra, like last times. Yeah, exactly. Do you do 100 steps or do you do the modular arithmetic? I'm like, look, last time we had linear algebra. This time we have modular arithmetic. I'm just saying the type of math we need has gone down. So, all right. Let's go get the real data here. Okay. Bump. So, step one, write a parser. No, step one, run all. There's our data. Now we collapse the data section and we write a parser. And let's go back to the quick input here. All right. All right. So if I want my parser here, right, we have this thing P04V3 minus 3. Okay. So what we're just quickly going to do is we have using int x, int y. I need an xy coord. My coords had been RC coords, and that's not going to be so helpful here, so using coord equals int x, int y. Okay. So now, let's just go ahead and say, we're going to put this on its own so we can use it in the next block using robot equals coord p, coord v. Oh, we have to run that first. Then we run that. Okay, so a coordinate is an xy. A robot is a pair of coordinates. All right, so now regex robot regex equals new at start of line p equals. Are they always? They aren't always going to be single digits. So backslash d plus, comma, backslash d plus, space v equals, backslash d plus, comma, backslash d plus, end of line, comma, regex options.multiline. All right, so now robot regex.matches data. Run. It found 2 of them. That's fewer than I expected it to find. Found 0013. Interesting. Here's a very dirty trick for the specifics here. Okay, don't share it with me. But tell me about it afterwards. But, like, yeah. Okay. So hang on. Why did only a couple of these work? The 0013 line worked. And the 9323 line worked. And nothing else did. Okay, slightly bewildered. Time to use a regex tool. regexer.com. There's an input. What have I done wrong? Visual debug tool. And flags, multi-line. Yep, only 2 of those got found. Okay. What is special about these 2 things? Oh, they're the only ones that... Oh, right. We might have a negative. Right. Minus question mark. Actually, there won't be a negative in the first set because the first sets must be on the board, but there can be negatives in that set. There we go. Those were the only 2 that didn't have a negative in them. Much easier to visualize when looking at the data in a tool like this. Grab it back. Paste it back. Rerun. And there they all are. Okay, great. And we have our values there. Great. So what we want to just do here is for each match in robot regex dot matches data chord pause chord p equals int dot parse p minus match dot groups 1 lowercase int dot parse match groups 1 comma int dot parse match groups 2. Okay, what's gone wrong? Oh, right. Dot value. Okay, then that's chord P. The other thing we're going to need is chord V, which is going to be 3 and 4. And now, instead, we're then going to say, hang on here, list of robots equals empty list. Great. And now robots.add PV. Capital add. And then tell me about your robots, please. Oh, right, sorry, add. We need to put extra parentheses in there because we're building a tuple. Boop. Robots. Okay, 0433. Let's just take a quick look at our data. Yeah, 043, -3. Yes, these robots are the robots we expect to see. Perfect. So now we're done with that. We can remove that extra little output and code, save, just in case we hang this somehow. All right, so now all we need to do is for each, actually, we're just going to say, robots.select. We're just going to transform our robots into, we need 2 other bits of data here. Int, yeah, our world is, can I have my world size here? Yeah, 11 while, width 11, height 7. Okay. And now we're just going to say robots select R goes to R dot P plus, oh, right. Hang on, using coord public static add coord A, coord B, coordinate A and coordinate to add coordinate A and coordinate B, we are simply going to return a new coordinate that is A dot X plus B dot X, comma, A dot Y plus B dot Y. Public static coord add. There we go. So now we can add those. So we're going to say add r.p, comma, r.v. We also are going to need to be able to multiply public static coord mult coord c int n goes to c dot x times n c dot y times n. Great. So we're going to add, then we're going to multiply the velocity times 100. And we also have one more thing here. Public static coord mod coord A coord B goes to A dot X modulo B dot X, A dot Y modulo B dot Y, and width is going to be, right, X is going to use height. Does it? No. No, X uses width. X is the across direction. Yeah, width, height. Okay. So we're going to multiply that by that, but after we multiply that, we also need to, no, we're going to need to take this whole thing, we're going to add all that, multiply that, and then mod all of that by size. What's gone wrong here? Oh, right, we need to run that so that those things exist. Now let's try running that. The name size did not exist in the current context because it's lowercase. Try again. Hey, cool. It did a thing. We'll see if I trust it. But, you know, hang on. Yeah, I don't want to try to track that. I've got my numbers there. So, okay. Let's go ahead and say, then we need to just do, var so final states equals robots.select. Okay. Run that. Next chunk of code, we want to do a quick quadrant count. So, let's see. Final states dot select S goes to, and we just want to select the quadrant here. So that's going to be, well, all right. We want some quick things here, which is int half width equals width over 2, int height equals height over 2, comment out this line, and I want to double check just here, tell me half width, half height. 5, 3. Will those be the middle cells? Hang on. 0, 0, 1, 2, 3, 4. Yes. Column 5 and 0, 1, 2, column 3. Excellent. 5 and 3 are the correct things. Wonderful. So now what I just want to do here is check. Whenever I do rounding, I always just want to let the system tell me how it rounds rather than remember the rules for how the systems round. All right, so we're going to select S where S goes to select S. Not sorry. Switch S. Or no, we want expression form switch. So it's going to be S switch. Yes, beautiful. Okay, so what we want to do here is we want to say oh, those need to be constants, don't they? For that to really hang on. C# switch pattern. Type tests, comparison tests, relational patterns. Test how variable compares to constants. Yeah. All right. Can I check? Oh no. X equals half width goes to. Can I do that? Oh no. Oh wait, hang on. No, S goes to X, Y. Cannot implicitly convert type int X int Y to int X int Y X int Y. Wait, and that's happening here. Okay, no, right. So Y doesn't come through like that. Hey, Mark Magus, welcome. Doing some Advent of code here. There we are. So if X is half width, goes pretty well so far. The name X does not exist in the code. Int X does not. Oh. Yeah. Another. Exactly. All right. So, right. So that's int X int Y dot X. Yes. Oh, hang on. S dot X. X. S dot Y. Y. Does that work? Now we have, yeah, X is half width, goes to null. Maybe? No. S is a variable used like a type. Okay. Hang on. I know that there's a decent way to switch on. Yeah, to switch on the pieces of a tuple. Here we go. On a record, order switch. Aha. Oh, we can just use the parts of the record. Wonderful. So what we just need to do here is we actually do just say it's an S dot switch. And then we can say X is half width. Ah, right. No. Oh, X colon half width. A constant value of type int is expected. Okay. Right, because those things have to be cool. We can use a slice pattern to apply to match 0 or more elements, right? Or in a list, yeah, lists. Okay, cool. So what we want to do here is if I've got this thing here, yeah. We're going to make those constants so that I can use them here. It means I need to pull them out myself, but that's fine. Okay, final state. So if X is a half width, we're going to return null. If Y is half height, null. So what's going on here is we're basically just telling it what to do in various situations. And now comes the fun stuff. X less than half width, Y less than half height. That's quadrant 1. And it doesn't matter how I identify these quadrants, really. The important thing is that we just identify them each differently. All right. Less than, greater than, less than, greater than, less than, greater than. Yep, we're going to need to do some explicit typing. That is fine in a moment here. All right. And then hit 2, 3, 4. Okay, so that just gives us each of the quadrants there. And this should give me, for final states, what quadrant each robot is in its final state. And I need to explicitly tell it, specify the type arguments explicitly. All right. All right. Right. I need to know what the type is there. Select. What are my type arguments there? I need T source, T result. Okay. So that's going to be coord int. Okay, what's going on there now? Cannot convert lambda expression because are not implicitly convertible. Coord, sorry, to int question mark. There we go. Everything's great. So now we run that, and we get back a list of coordinates, none of which are null. That's concerning. Show me final states again. Oh, wait, some of these are negative.